Hello and welcome to today's presentation in which we are going to cover this topic of managing authorization and access control in Elixir code bases. We'll, as the subtitle states, have a bit of case studies and show some practical solutions using Elixir, for which we'll mainly present a library that we have developed for making our lives easier. So this is a brief one about me, and I didn't draw this, as you probably guessed. My name is Michał. I am the CTO at Curiosum. We are a Poznań, Poland-based Elixir consultancy. You can meet us at the booth in the lobby. By the way, as you probably have seen, the printed ebooks are gone, but you still can download this. So feel free to do so and feel invited to come to the booth. So you can visit us there at https://curiosum.com. All right, so let's discuss authorization and access control. And just to be fully clear, this talk is only going to cover authorization, not authentication. So we're not going to be dealing with anything like Phoenix Gen Auth and so on. We're also not going to be talking about API authorization, so OAuth, OpenID, and these kind of things are out of scope of this talk, but these are obviously also interesting subjects that we could touch on in the future. So what's the topical focus for today? Authorization paradigms and architectures. We'll discuss some structures of how permission control is done in code bases and how we can define permissions for resources we manage. We will review which of these paradigms and architectures are realized by specific libraries on the Elixir market. We'll talk about some of the common concerns we see in Elixir projects that may be pain points to some extent. And lastly, we'll talk about how we streamline authorization with our permit library. So the first one is authorization paradigms and architectures. And there are a few approaches to access control and several notable top-level architectures we can use. And the first one, which might be seen as trivial, is ACL, which is access control lists. And this is basically a structure in which we declare who can do what on what. So basically, it's very specific about what identifies the subject, what identifies the action, and what identifies the object. So we have kind of allow and deny list. So the advantage is that, for example, if we use ETS, we have O1 lookups, but obviously, if we wanted to implement this in a complex system, we get rule explosion because we have to add this kind of entry for all users and possibly all resources that we need to cover. So that's one thing. The second one we can talk about is RBAC, which is role-based access control. Users are assigned with roles, which in turn are assigned with permissions. This has obviously the advantage of auditability and clarity because assignment to roles and the permissions in those roles is very clear. But we can fall into role creep, which means that we can run into having dozens of near duplicates for special cases if we end up doing this. Then we have ABAC, which is attribute-based access control, which is basically something like allow to perform a certain action if a number of specific attribute conditions are satisfied. And this is what we'll be showing for the permit library because this model is effectively realized by it. And the advantage is flexibility and the power of expression because we can do pretty much all possible architectures of authorization with this kind of structure. But there is also some combinatorial policy sprawl, and we need to be quite careful in terms of testing out stuff because the engine might be well tested, but the implementation of the rules themselves is up to us, so it's our responsibility. And then we have REBAC, which is relationship-based access control, which is quite interesting and realized by some systems like Google Zanzibar, Ecto, Zephyr, Auth, and this means that we are actually speaking about relationships between users and resources in terms of whether, for example, a user is the owner of a resource, or maybe a user is an editor of a resource, right? And this is how we model access control rules, which has an advantage in social graphs, perhaps collaborative sharing, editing tools like shared drives and these kind of things. But the risk is obviously added complexity of linking entities, because the reasoning is not as straightforward. And then we have policy-based access control, which is implemented by quite a few libraries, even in the Elixir world. It's Bodyguard. A lightweight implementation is also in Canary. In a certain way, it's also Ash policies and the Let Me DSL, and also OPA, which is like authorization as a service. The advantage of this is readability and the power of expression we have here. It's easy to read, to review, to eyeball this by developers when doing code review and this kind of things. But especially with DSLs, there is a bit of a steeper maybe learning curve, and we might run into some issues debugging this. So we also have some potential dilemmas about keeping stuff inside the beam, let's say, which is what Bodyguard, Permit, Ash policy, and all these kind of things do. And the advantages are obviously we have almost no latencies, no extra infrastructure. The implementation is relatively simple, but it requires custom UIs in most of the cases, and the proper approach to data model design to achieve the flexibility we need. But it wins in monolithic and stable designs, while we are also able to offload this authorization aspect to external libraries outside the beam, which is Zanzibar, Cedar, Casbin, OPA, Ecto, SpiceDB, or even you can say that about Postgres RLS. This obviously has an advantage when dealing with a polyglot system, so you don't have to repeat yourself and rewrite the authorization rules for each part. Those tools tend to have integrated UIs for live updates, which also makes it easier for governance and oversight. But obviously, the risks include network hop, unless this is kind of shared in a specialized infrastructure to do that. Extra moving parts, because this is an external system after all, and cost and data residency issues. So obviously it wins in polyglot and multi-team settings, so that's up to the developer which one to use. So some of the common concerns we hit in Elixir projects in web and not only web is, first of all, the repetition and the lack of a single source of truth for what we want to do, which is especially connected to the load and authorize pattern. We often use in, for example, Phoenix controllers, LiveViews, GraphQL resolvers, and this kind of stuff. Plug boilerplate. If we decide to write this kind of mechanism ourselves, we end up with some additional code that's just there for the sake of being there. Power of expression, which is something we need to be reasoning about when designing the right system for our specific use case, and also multi-tenancy implementation, which is yet another complex thing we need to care about. So just to give you some practical examples, in this specific case, which is like a system for managing pools of devices, the thing about data structures there and the reasoning behind permissions was that there was plenty of permission cascading down the resource tree. So we basically created a system which is like a hybrid between attribute-based access control and role-based access control. So users were organized in teams that have predefined sets of permissions with distinct hard-coded roles, several levels of permissions, and also permission checks in Phoenix LiveView event handlers, and a plug to support it all in controllers. And the other one is like a medical clinic management software at which we use strict router level separation between areas accessible by system administrators and roles within the clinic, and within that we also use the permit library to implement a role-based system. So that's kind of the two levels at which we did that in that specific case. So here comes the next part, which I'm pretty excited to tell you about. And we're gonna talk about the permit library we written. Actually, this is something consisting of 4 libraries right now, which is the base one, the permit Ecto, which provides an Ecto integration, permit Phoenix, which provides the Phoenix and Phoenix LiveView integrations, as well as the new one, upcoming permit Absinthe, which is going to, as the title says, be an Absinthe integration. And let's go into more detail right now. Some of the patterns and features we liked when dealing with authorization to make our lives easier. We like stuff that's written that can be exposed as an API in plain Elixir without an additional DSL. And I'm not an anti-fan of DSLs per se, but I'm just trying not to force anyone to learn another one just because I like that. So that's our approach to this. We want to have a single source of truth for all the, let's say, frameworks or components of the app that we want to use the authorization in, because we don't want to repeat ourselves with any related code in controllers, live views, and all the layers that actually deal with accessing data, which is related to the load and authorize pattern. So for single resources as well as lists, we want to be able to just enter the controller action, for example, or a LiveView event handler, or a LiveView handle params implementation when we navigate, when there is an event processed. And based on that, we want to plug in with something that has the record loaded and authorized. And in case it's not, then we have a handler which deals with the unauthorized case, right? We want stuff to be powered by Ecto, but at the same time not tightly coupled to that, because obviously not everyone's using Ecto as the data access layer. So we want this Ecto integration to be opt-in and not forced to anyone to add this dependency if they don't need to. The same goes to Phoenix, Phoenix LiveView, Absinthe, and anything else. That's why it's 4 libraries as opposed to 1. We want this to be seamless with Plug and LiveView, as I said, and potentially others. So there is a way to actually produce. There's an API you can use to produce your own integration with any other framework you want this to be integrated to. So this is framework decoupled. And some of the inspirations we had before, Ruby's can or can. After the first one got discontinued, we liked it. It did plenty of. It satisfied plenty of the assumptions we told you about. There is a convenient manner of defining rules, generating queries to index accessible records. It's backed by DB, and there is obviously the load and authorize pattern. But as we adapted this to Elixir, according to our own requirements, we shifted to a DSL-free syntax because CanCan was kind of a heavy DSL. CanCan also used to provide the cannot declaration, and we found this confusing in large rule sets, so we decided only to allow positive declarations. So only stuff which is explicitly declared as authorized is actually authorized. We wanted this to be integrated with LiveView, and as I said, potentially others, and we wanted this to be modular and loosely coupled to stuff. So this is how you define conditions in permit. And there is the authorization module, which uses permit and the specific applications permissions module, and then then you plug in an actions module, which defines your actions that you are going to be reasoned about. Actually, if you use this in controllers, which we cover later, it reads the actions out from controllers as well as from live actions defined in the router, so that makes life easier. But then you, for example, for the admins, you permit to do everything on the article entity, and for anyone else than admins, for users that don't match that, you allow them to do everything on an article whose, actually there's a typo there, it should be user ID is the same as the user's ID, and you allow them to read all articles regardless of conditions, but all the other actions are only permitted for their own ones. So permission definitions are loaded from a single module. Functions like all, read, create, update, and so on are generated corresponding to actions defined in an actions module. Conditions are given via conditions list, via keyword lists, and the all function grants permission to all possible actions. And then when it comes to checking the permissions, we still do this in a plain Elixir way. So the can function actually constructs a struct we use to ask it whether a certain permission is given. So if we granted the read permission without the question mark here, then the read question mark here function is going to ask whether that permission was granted. And obviously the argument of the can function is the subject, which is the current user. So in terms of the paradigm, we could say that the model is primarily attribute-based, implemented as policy as code in a way. And ACL, RBAC, and REBAC are reducible to permits ABAC model. So you can see that these three examples are related to, well, that one in the bottom left is ACL because there is a specific user ID in play. Oh no, I'm actually confusing something. This is no, this one since is ACL. Sorry, that one is REBAC. So we have a user. We take the specific ID of this user, and this article entity is associated with the permissions entity, which contains an information about what action on what resource this user is permitted to do. The one to the top left is RBAC, so we have a clear role there. And the one at the bottom right is REBAC, in which the related entity is named relations, and you can see that we permit this if only if this specific user has the writer relationship with that article. So now let's talk about permit and Ecto, which is the DB-backed authorization. And I am not speaking about using the native Postgres row-level security here, and I'm aware that it's something that we probably would like to explore later on. But let's see what we can achieve with this. So, because conditions are given as keyword lists, we can automatically construct queries out of them. We configure this within Ecto repository. Instead of permit permissions, we use permit Ecto permissions. And then we have the same authorization condition syntax with a small caveat that I'm going to cover soon. Conditions can be based on nested associations. And then what the Ecto integration brings into the table is that you can allow someone to, for example, read an article that matches conditions given as, for example, an I like syntax, which if you want to do this check on purely the Elixir side and ask whether a specific record is, a specific user has an authorization to do something on a specific record, this gets converted to a regular expression. So you can specify rules like this, but then ask not only via a generated query, but also through a plain Elixir function. So in this case, the read permission is given on an article that matches 3 conditions at once. So the code matches public dash whatever. Status is not equal to hidden. You can see that the operator is given via the tuple. And the status is also in a specific list, which is also translated to the in operator in SQL. Yeah, so convenience atoms provided for comparison operators, as you see. Regex compilation of ILike and retrieving accessible records via generated query. So you can use the accessible by function to hit that specific query. I know it's not easily legible, but under the hood, this query is generated based on the rules we have. So that's probably it about permit Ecto. Now let's go to permit Phoenix, which is first DRY authorization in controllers. So what we want to avoid is copy-pasting authorization boilerplate. We want to have as little of that as possible. We don't want to forget to authorize an action. So if this mechanism is enabled globally for a specific controller, then then we're good to go. We don't want to mix authorization rules with controller code, which also happens some of the time. Out of rush or whatever else. We want to filter out inaccessible records using a plain query and not have to ask for that for each loaded record, and we don't want the error handling in our controllers to be inconsistent. We would like to have a way to devise a common handler. So the load and authorize pattern is facilitated by plugging this into the controller, pointing to our application's authorization module. For the controller, we specify the related Ecto schema in this case, the resource module, which is article. And this can be done even more dry if we use the MyAppWeb module to put some options in the use opts, and then in specific controllers override them using functions. So now, in terms of how to handle failures, we have this handle unauthorized callback, which is optional and defaults to redirecting to a specific fallback path, which in turn default to the root path. It can be implemented at a specific controller or globally as just with the resource module option. And it obviously has access to the plug con and the permit action we attempt for the sake of pattern matching. So if we want to have different implementations for different actions, then we're good to go. And we can also have control over how the query is built. So in case we, for example, have a route that first has the article ID and then we want to, for example, index comments of that article, then in the base query, callback, we can pre-process the query based on, for example, the controller params, the action we are doing. And in this case, it's handy to filter out by article ID, and we also have the finalized query callback we can use to post-process the query. So other notable customization options can be given as option keyword lists or by implementing callbacks just as before. Among them are the except option, which is opt-out. So just for the sake of security, the opt-out thing is much better than an opt-in solution. Fallback path, where to go after authorization error if the default callback is used. Handle not found, which is also self-explanatory and works similarly. ID param name and ID struct field name if we use stacks or UIDs as identifiers of the records in the roots. And also we can specify which actions are singular and which are plural. So obviously it looks like an index action is singular and is plural, and a show action would be singular. So now let's have a look at how it works with LiveView for authorizing LiveView navigation and events. First, we need to hook into the router. So we have the permit Phoenix LiveView authorize hook, which hooks into handle event and handle params on mount. Permit actions are matched against the live action names from the router. So we have index new and edit specified here, and this will be what will be matched against. And between permit actions and event names, you can do a customizable mapping. So if you have an event named, for example, update, you can also map this to the update action in your permission set. So this is how live action is mapped to permit actions. So this is an exact match, and it's quite easy to implement with pattern matching and creating clauses for each live action. Like here, if the live action is edit, we assign something specific from assigns loaded resource. The title, actually I know we should be using streams here, but for the time being you can just stream this from this assign. And also authorizing navigation and events, if you specify this event mapping from event names to permit action names, you can do this kind of authorization for events as well. Instead of basing this on a live action, this is all based on the mapping, and you get loaded resource, for example, into the assigns based on the result of the authorization. So just as in this example of the handling the delete event. In terms of handling failures, we follow the standard conventions of LiveView, which uses continue or halt. So we are good to go in terms of how we go about doing this while mounting or in place. Actually, the mounting function is, I think, written by us just for convenience purposes. And to customize this, we can do a similar thing to the one which we are doing in controllers. So we can do this in the opts keyword lists of use, as well as specific callback implementations inside the LiveView module. Right, so that's it about permit Phoenix LiveView and permit Phoenix. And now the upcoming thing, permit and Absinthe, which is a tool for authorizing access to resources in GraphQL APIs. And this one is something we had a bit tough time reasoning about because of obviously of the structure of how GraphQL looks like, and because there are queries and mutations and not necessarily mappable directly to action names per se. So we decided to, first of all, we have to map a specific type of an object to an Ecto schema. This is plain Absinthe meta under the hood. And the plugin in of this is similar to what we've seen in controllers. And then we map fields to actions in both queries and mutations. And most of the time, mapping query fields to actions is going to be about specifying the read action. But for mutations, it's going to be a variety of different stuff. So in this case, the update article mutation is mapped to the update action from permit. And then we can, we have this possibility of using the simple resolver function we created. So we have this load and authorize all and load and authorize one functions to preload plural and singular resources respectively. And if in case it's not enough, we can also do this via middleware. So this works analogously, but then we can write our own resolver function to consume the result of that middleware working. So the records are preloaded into the resolution context. Right. So in terms of future directions and ideas, we can obviously utilize Phoenix streams as well as scopes, the new feature. Which makes a lot of sense when dealing with, let's say, constructed sets of permissions. We can think of integrating this with, for example, commanded, or trying to figure out how it can play with hash policies. Maybe one of them can be translated to the other. We can obviously do research on how we can use row-level security in addition to this. Maybe we can do conversion of the rules we write to DDL statements. I don't know. Policy playground and visualizer, which could be very handy for the purpose of constructing those permission sets. Audit static checking of permissions, whether every controller is covered, maybe caching and compile time optimizations, which is something we haven't covered yet. And up for discussion is field authorization, because that's what some people ask for. But to us at this stage, it's a little bit out of scope, but I'm open to discussion about this. And also maybe Phoenix route checking, because at this point we just don't do that. So your ideas are very welcome. Please feel invited to contribute in any way, test out permit and other related libraries in practice, and do share your opinions on how stable and usable and helpful it is for you. So on our GitHub, you are obviously invited to submit ideas for improvement, report backs, contribute pull requests, discuss. Yeah, I think that's it from me. You have the repository links down here. Yeah, it was a pleasure to host this talk. Thank you very much for listening.
Thank you, Michał. Great talk. I have a question from the app. Did you consider Ash?
I have, but the point of this is to actually be an alternative that doesn't rely on any of the components of Ash, so that there is a choice. I think using one doesn't contradict each other. I'm going to try finding a way to kind of make them two play together. So this is still up for discussion. I'm obviously open to discussing that.
Thanks. Any questions? Feel free to raise a hand. Okay.
I just assume that everything is based upon what's written in the database at the time. So like from a new enemies problem kind of point of view, it's just if somebody's permissions have been removed, it's removed from the database, and then you're just when you hit it, that's how it's resolving.
So I'm not sure I understand the question. So are you asking about the way it's resolving the? Okay, so basically. Okay, basically, okay, this is all written as code, so any change is compiled. But if you specify this as based on some relationship between entities, let me just come back to that thing in Premit Ecto. So as you see, let's maybe use another slide, this one. If there is a relationship between articles and relations, that's like a separate entity, and you remove a record from the relations table, then I think that's what you are trying to do, right? If you want to do a UI in which you can remove permissions on the fly, this is the way to go.
Right, back here. I have a question relating to Absinthe and more GraphQL oriented. I'm wondering, have you considered, or like maybe it's a bit technical, GraphQL has directives and they kind of work sort of kind of like middlewares, right? So have you considered integrating permit there? Like what's the angle there? Is there an opportunity, and why not do something with it?
We are at a very early stage with this one. It was just, honestly, I wrote this a few days ago in like 30 minutes, and this was the first thing that came to my mind. It's just a simple proof of concept right now. So maybe before we hit even the 0.1 version, it's gonna look like that. I'm totally open to this.